Hello, class 12 students, Aggarwal students. Welcome once again to Math is Possible. I am continuing your video for the chapter Continuity and Differentiability. Let's go on to question number 9. I have done till question number 8. Exercise number 5.1. Okay. So now this is question number 9. Exercise 5.1. Let's write something over here. Let's write it here. Exercise 5.1, question number 8. It says f of x is given to you as 3x minus 8. Put it in bracket. 3x minus 8 when x is less than equal to 5, and 2k when x is greater than 5. It says find k so that f is continuous at x equal to 5. So it already says that the function is continuous. So if the function is continuous, you know what is the rule? That means limit of x tends to 5 negative, f of x is equal to limit of x tends to 5 positive, f of x is equal to f of x. Okay, or f of c actually, f of c, the value that you are going to put over here in place of x. Okay, so when this becomes equal, what is this whole thing? This means this part is the left hand limit, LHL. This part is the right hand limit, and this is the value of the function at the indicated point. And what is the indicated point here? X equal to 5. So this 5 in place of x, here you will have to put that 5. You already know. So let's start. Now this criteria is already satisfying. That means it's already continuous. Now you just have to check the value of x. That means this is equal to this. Okay, so LHL is equal to RHL. Start. This is limit of x tends to 5 negative, f of x is equal to limit of x tends to 5 positive, f of x. So this is negative part. So when less than or equal to, then you will have to use that function. So that is 3x, limit x tends to 5 negative, 3x minus 8 is equal to limit x tends to 5 positive. When it's greater than 5, 2k. Okay, put the 5 over here. Over here you cannot put the 5 because that's 2k, that's a constant that will remain like that. Okay, so this 5 threes are 15, 15 minus 8, 8, 9, 10, 11, 12, 13, 14, 15, 5, 6, 7. So this is 7 and that is 2k, okay, which implies from here 7 by 2 is equal to k, right? 8, 9, 10, 11, 12, 13, 14, 15, 5, 6, 7. 7 by 2 equals to k. That's the value of k. Let's check it out. Exercise 5.1, question number 9. Exercise 5.1, question number 9, 7 by 2, correct answer. Okay, this answer is correct. Alright, let's go on to the next question. Question number 10. Okay, let's pick this question. I have done it. Question number 9. Let's go on to question number 10. easy question, might come for your exam. Okay, not important, but okay, if it comes in the compulsory section, come for 1 or 2 marks. 1 mark. Okay, not 2. Question number 10. Question number 10 says, these are easy questions, okay? These you can practice. The ones that are little difficult, that you will have to do. This is just the starting, nothing actually. F of x is this, divided by x square. Okay, put this. There are two things over there. X square minus 2x minus 3. Okay. X is not equal to 3 and k when x is equal to 3. Alright. So it says find the value of k. Says actually find k such that f is continuous at x equal to 3. Always looking at the wrong question. Or at x equal to 3. So let's start. It is continuous at x equal to 3. So that means RHL is equal to LHL is equal to f of c. Right? Simple way to write. Okay. Now you start. RHL equal to LHL. So limit x tends to 3 plus, right? F of x is equal to limit x tends to 3 minus f of x. Alright. Now look at this. Look at this part. In both these parts, the answer will come the same thing. Okay. So you have to write is also equal to f of c. Now why the answer will come to the same thing? Look at this. Okay. Just look at this. This is not equal to 3 because it's approaching from the right hand side to 3. Let's say this is 1, this is 2, this is 3. 1, 2, 3. So the graph is approaching 3 from the right hand side. So that means it's not equal to 3. It's more than 3. So if it's not equal to 3, you will use this function. Again, when it's approaching from this side of 3, say like this kind, it's approaching 3. Again, it's not equal to 3, it's less than 3, let's say 2.9 or something like that. Again, if it's not equal to 3, then you will use this. So instead of writing both these things, right, instead of doing same thing for both these things, you just write this equal to now this. That's enough. So limit of x tends to 3 plus, alright, x square minus x square minus x minus 6 divide by x square minus 2x minus 3 is equal to f of 3. So when x is equal to 3, then f of 3 is equal to k. So instead of f of 3, next I'll put k. Now you don't go ahead and put 3 over here, okay, because if you're putting 3 over here, this is 3 3s are 9 and that is 3 2s are 6. 6, 7, 8, 9. 9 minus 9, you're getting a 0 in the denominator. So now what you have to do, your normal quadratic equation, midterm break, okay. You're in class 12, you know what to do, okay. So this is x square minus say 3 minus 2 x minus 6 bracket closed divided by x square minus 3 minus 1 x minus 3 is equal to k. Alright. Finally, let's go on top. equals to 3 plus x square minus 3x plus 2x minus 6. That's the first part, divided by x square minus 3x plus x minus 3. So the second part equals to k. So that is limit of x tends to 3 plus x, x minus 3 plus 2, x minus 3, divided by x, x minus 3 plus 1, x minus 3 is equal to k. So limit x tends to 3 plus x minus 3, x plus 2 divided by x minus 3 and x plus 1 equals to k. I solved so much for you. You don't do like that. Okay, from this you can directly come on to this step. Okay, you don't have to do this. From this step directly, if you can understand, you come on to this step. Now limit of, now after this you don't have to do this step also. You can just put the value of 3. Okay, x tends to 3 plus, those of you who want to see this also, you can see. Okay, x plus 1 equals to k. 3, so now you put 3, 3 plus 2, 5. Over here 3, 3 plus 1, 4 is equal to k. Okay, let's check the answer. Question number, what was that? Question number 10. Question number 10, 5 by 4. Correct answer. Let's go on to question number 11. Okay, now this is an important question. Question number 11, important question. Okay, although it is a similar type of a question, same I mean, but it's important. Not same, similar. There's a difference between the two words. I'll show you mathematically also. That's actually in class 9 students, I'll show. But you already know it. Question number 11. Question number 11 is given as f of x is equal to tan 3x divided by kx. X is not equal to 0 and 1 when x is equal to 0. Find k. It says find k such that f, not capital, such that f, the function, is continuous at x equal to 0. X equal to 0, correct. Okay, so let's start. Okay, how? Simple. RHL equal to LHL equal to f of c. You can use any, either this equal to this equal to this, or this equal to this. They are, all three of them are equal to each other. Now start. Alright, let's start with the RHL. So that is limit of x tends to 0 positive. F of x is equal to, now don't need to write the negative part, because when it's not equal to 0, this will happen. Okay, when it's not equal to 0, you have to take this function. When it's equal to 0, you have to take 1. So now f of c direct you have to write. So this is limit of x tends to 0 plus, okay, tan 3x divided by k is equal to 1. Alright, now those of you class 11, you all have studied limit of x tends to 0, tan x by x is equal to what? Everybody knows, equal to 1. You all have studied this formula, right? Limit of x tends to 0, tan x by x is equal to 1. So that means limit of x tends to 0, tan 2x by tan tan 2x by 2x is equal to 1. That implies limit of x tends to 0, tan 3x divided by 3x is equal to 1. So that implies, if we continue that way, limit of x tends to 0, tan nx divided by nx is equal to 1. Alright. So this is 3x. That means we have to divide by 3x. So go ahead and divide the top part by 3x. 0 plus tan 3x divided by 3x. Don't worry about it. Don't worry anything. Now look at this very carefully. This top part you have divided by 3. I want you to get rid of the 3. How will you get rid of the 3? By multiplying a 3 over here. Right? Look, I want to get rid of the 3. So I will multiply a 3 over here. When I multiply a 3, the 3 and the 3 over here is getting cancelled out. X equal to 1, right? X equal to 1. Yeah. 3 and the 3 is getting cancelled out over here. But what about the x? So over here kx it is. Kx, right? Yeah. Kx divided by an x equals to 1. Understood? Understood? So from here now, what do we have? This 3 will come outside. This 3 is going to come outside. Why? Because 3 is a constant and the limit will get multiplied. Over here you cancel out the x and the x. The 3 comes out and the k also comes out. K is also a constant. Now inside what can you write? Limit of x tends to 0 plus tan 3x divided by 3x. Okay? Is equal to 1. Right? Look at this. Look from here what happened. I divided this by 3x. Now I got to get rid of the 3. Why? Because actually I got to get rid of the 3x. Okay. But first let's think about the 3. How do I get rid of the 3? 3 I get rid by multiplying another 3 over here. And how to get rid of the x again? By dividing another x away. So this x and this x actually gets cancelled out. This 3 and this 3 gets cancelled out. And you're left with tan 3x by kx. See, if I do over here, tan 3x divided by 3x into 3 and kx divided by x. I have done this. See, the x and the x got cancelled out. Okay. The 3 and the 3 got cancelled out. What are you left with? Tan 3x divided by kx. So very simple, right? Now from here your work is done. This is 1. See, the answer over there is written. So this is 3 by k is equal to 1. Then 3 is equal to k. So k is equal to 3. Let's check this answer. Question number 11. 11 correct answer. Answer is correct. And did I check the answer for question number 10? If I didn't check the answer for question number 10, then let me tell you, yeah, I had checked 5 by 4. I told you 5 by 4. Right. So question number 11 is finished. Let's go on to question number 12. Let's do question number 13. And that's it for today. We will continue this chapter in the next video. Very long chapter. Let me tell you, we got a long way to go. I don't know how many parts of this chapter I will have to make, but this is a very, very long chapter. Okay, there are many exercises. It's going to be fun, but okay. So let's go on to question number 12. Question number 11 was important. Question number 11 I just now did for you. It was an important question. Please mark it. Okay. Question number 12. Question number 12, it says that the function f of x is equals to tan x. It's defined by f of x equals to tan x. They are asking, is it continuous? At x equal to pi by 2? Is it continuous at x equal to pi by 2? Okay, those of you who know how to make the table, okay, very good. Those of you who remember the table, that's even better. But this is how the table goes. Everybody knows actually. Class 12 students, you all know how to make the table. Okay, very simple. 0 degree, 30 degree, 45 degree, 60 degree, and the final one is 90 degree. 0 degree, 0 degree, 0 degree. Okay, this is pi, that is 180 by 6 3s are 18, that is pi by 4. This is pi by 3 6s are, and this is pi by 2. So they are talking about pi by 2. They are talking about this column for tan, the function, whether the function is continuous or not. So first you have to actually check whether the function is existing. If the function does not exist at that point, so it cannot be continuous. Okay, so let's check sine whatever, sine 0 degree, sine 30 degree. So first one 0 by 4, second one 1 by 4, third one 2 by 4, then 3 by 4, then 4 by 4. Finished for sine. Cos, just the opposite, 4 by 4, 3 by 4, 2 by 4, 1 by 4, and 0 by 4. Now any trigonometrical value you need, you can find out. All you need to remember is the sine and the cos. What is tan? Tan whatever is sine whatever by cos whatever. So sine by cos, pi by 2, look at this. This is 4 by 4, that is 1. Root over 1 means 1. So this is 1 and this is 0. 1 by 0, not possible, does not exist. Does not exist. Hence, what will you write? Limit, direct, limit x tends to no plus, no minus. X tends to pi by 2 tan x is equal to does not exist. Finished. That's it. Hence, f is not continuous. F is not continuous. You can see 1 by 0 doesn't have any value, so it's not continuous. Pi by 2. So at tan pi by 2, you're getting tan theta as does not exist. Okay, so you can find anything. If you want to find sec, then you have to do 1 by cos. If you want to find cosec, then you have to do 1 by sine. If you want to find cot, then you have to do cos by sine. Whichever value you want to find, 60, 45, 30, anything. So now question number 12 is also done. This question is also important. Please do mark it. Okay, this question is important, although it looks like a very simple question, but still mark it important. Okay, let's go on to the last question for today, question number 13, and this video is over, this part. Question number 30, simple question, but still mark it important. Put 1 star, that's enough. Okay, it says f of x is equal to mod x. Mod x means absolute value, positive, the x will come out in a positive form. Okay, so continuous, is it continuous? Is f continuous at x equal to 0? 0, right? Yeah, 0. So check LHL, is it continuous? So limit of, so f of x when coming out of the mod sign becomes x only, right? Keep it as x only. So limit of x tends to 0. Okay, negative f of x is equal to limit of x tends to 0 mod x is equal to limit of x tends to 0 x is equal to 0. Finished? Simply do. Okay, RHL limit of x tends to 0 plus f of x is equal to limit of x tends to 0 plus x is equal to 0. Simply 2. That's what I am trying to say. Now f of 0 is equal to 0. Put 0 here. That's a 0. So LHL equal to RHL equal to f of 0. Hence f is continuous at x equal to 0. Finally, we are done with question number 13 also. Okay, let's just check the answer, confirm it. Question number 13, it says yes. Okay, that's it for today. We shall continue this chapter in the next video. Okay, so keep taking as much help as possible from my channel, Math is Possible. See you in the next video. Bye bye.